Do you guys know about black screen or just me? Huh? Yeah. Yeah, but do you guys know that you can use black screen that way? I have to say that's pretty creative. Instead equal to 0, you're gonna solve for x equal to 0, x equal to 1. Yeah, you factor out x and you can solve for it. Yeah. Yeah.
X equals 1 where it is. X equals 1 would be incomplete. Yeah, G 2x equals 0. And x equals 0. Oh, I did negative pi over 6. Same thing as 11 pi over 6.
All right, so today we're gonna talk about product rule. Product rule, it doesn't seem. Product rule and quotient rule, we're gonna talk about both rules at the same time. So that way we can save time. So first of all, what is a product rule? Product for math is called something times something. It's product of 2 and 3. That means 2 times 3. So let's just say if I take a derivative of a two function multiply each other, f of x times g of x. Is equal to f prime of x times g of x plus f of x times g prime of x. I also called it as left d right and plus right d left. So it doesn't matter which order you do. You do right d left first, then just gonna add it left d right, or left d right add it right d left. So I'm gonna show you how to work. So let's just say if today I want to take a derivative of two functions, and we're gonna label this color. So one is a blue function, which is 2x minus 5. And one is the black function, which is 3x squared minus 2. And so I want to take derivative of those two functions. Now, ideally, you can probably say, Mr. Ye, I don't really need to take derivative of two functions. I can always distribute it and derivative with the power rule. Yes, it will work. But for today's purpose, you guys have to know product rule. And we're going to explain to you why you need a product rule as opposed of, just using it. So we're going to call this blue function as f of x. And the black function, we're going to call it g of x. And according to this, according to the rule, they say f prime of g of x. So I'm going to say, let's take derivative of f of x first. Derivative of f of x is what? Just 2, right? And just leave the first one alone. Leave the second one alone, minus 2, like this. Now it's going to be adding. And now I'm going to leave the first one alone. I'm going to use the blue color to represent the first one. And take a derivative of the second one, which is 6x. You just finished to take a derivative of product rule. The only thing you have to do is distribute them. So it'll be 6x squared minus 4 plus 12x squared minus 30x. And that's equal to 18x squared minus 30x minus 4. And that's it. You just take a derivative. No, actually distributing is faster. but we're going to talk about why you needed this rule. Okay, so I'm going to show you distributing. So let's just say without product rule, it's actually better. But the problem for today's purpose, you have to use product rule. It doesn't matter what, you have to use product rule. Because there are questions that you're gonna have to use product rule as opposed without using it. So without using product rule, this will look like this. So if I take a derivative of this function, I can also distribute them and just say d to the dx of 6x to the third minus 4x minus 15x squared and then plus 10. If I take a derivative of this, it's going to be 18x squared minus 30x minus 4. And the answer is going to be like this, exactly matched up. And so you say, well, what's the point if I use product rule, right? First of all, let's just make sure you guys know how to use product rule. Let's just say, hey, I want to take a derivative of this function. Let's say 3x plus 4 and 6x squared minus 1. And I want to take a derivative of this function. And let's see if you can use product rule correctly. But make sure you only can use product rule, not distributing. Distributing doesn't mean that's nice done. Cool. If you're done, check another friend, see if they get the same thing as you. Now, of course, don't use So you don't need to be a rocket scientist to figure out. Let's take a derivative of 3x plus 4 first. So it's 3 times 6x squared minus 1 plus 3x plus 4 times 12x. Did you do that? And that's going to give you 18x squared minus 3 plus 36x squared plus 48x. And that's equal to 54x squared plus 48x minus 3. Did you guys get something? Why do we need to use this? For right now, because you don't know chain rule. By next week, you'll know chain rule. And chain rule, then you have to use product rule and chain rule combinations. But as of this moment, you cannot. So I'm going to show you another example of why you have to use product rule. For example, x squared times sine of x. And I have y equal to x squared sine of x. I say, hey, let's take product rule of this. Now, why do I have to use product rule? As opposed to previous case, you can distribute in. In this case, x squared cannot distribute inside. because this is what we know as argument. X is within the sign of X. So you cannot distribute the X squared inside. That's not gonna how it work. So you're gonna say, okay, well, this is a product rule. Yes.
So you couldn't just do the derivative of each one and then multiply?
No. That's what a lot of people do on their tests. And that's what will be the first people I marked it wrong. You cannot take a derivative of x squared, get 2x, and derivative of sine of x equal to cosine of x. No. You have to treat it as they are two functions. Like this is a two function multiply each other. X squared and sine of x. So let's take prime. Then it's going to be 2x sine of x plus x squared times cosine of x. So that, and that's it. There's nothing you can do. That's your final answer. 2x sine of x plus x squared cosine of x. You can factor out x. That's not so much as you can do. Okay, so I'm going to give you a second case. Remember, this one you cannot distribute. No other way but product rule. Okay, so the next case is y is equal to 2x cosine of x. And next case is in minus 2 sine of x. Do you see product rule? And where is the product rule located? Anybody can tell me where's the product rule located? Yeah, that's the only part has a product rule. Now this one, this is a product rule because there are two functions multiply each other. The second one is not 2x sine of x, it's actually 2 sine of x. This is actually called a constant multiple rule. So it's like taking derivative of 2x squared. Just take a derivative of x squared times 2. That's equal to that. So let's do product rule. So 2 cosine of x, right? Plus 2x times the negative sine of x minus 2 sine of x. Oh, not 2 sine of x. Derivative of sine of x is what? 2 cosine of x, right? Does that make sense so far? Now can this thing cancel out? So it'll be negative 2x sine of x. Where do I get negative sign? Is derivative of the cosine of x is equal to negative sine of x. Because I leave the first term alone, take a derivative of cosine of x equal to negative sine of x. Questions? Yes.
So do you only use the product rule when x is multiplying like sine of x or like cosine of x?
Yes, of now. Later on, we have like x plus 2 to the 4th power times x plus 8 to the 8th power. Then you have to use product rule still. But later on, we're going to learn another rule called chain rule. But right now, we don't have that lecture yet, so we only can use product rule. Because we can learn one rule at a time. And here's product. Yes, Amir?
What was the last time or last week we wrote down the rule about f of x minus g of x and then f prime of x minus g prime of x? Is there a name for that?
Yeah, that's called sum rule and the difference rule. Okay. And that one's, it's pretty easy to understand. So this one's a little harder. Now we're going to show you another rule. We're going to call this h of x, and we're going to call this f of x over g of x. And if I take a derivative of this case, and so for me, I'm going to give a name for this. I'm going to give you the top function called high, and low function is called low. Okay, so high, low, which is numerator and denominator. With the being said, there is an acronym that's being passed down from generations. It's been passed down from my teacher, from my teacher's teacher, from my teacher's teacher, teacher. So just this acronym is going to help you memorize this rule because it's kind of complicated. It's going to be low d high minus high d low over low squared. So low d high minus high d low over low low. So I'm going to show you how to do it. If I take a derivative of this, it's going to be low d high minus high d low over low low. Now what people usually forget is they forget the bottom part. So don't forget the bottom. Don't forget bottom with g of x squared. Do not. And don't forget square. So some people forget the square. And don't expand. Don't expand on the bottom. So now I want you to try to take a derivative of this. Do you guys take a derivative of this? Try to copy it. I'm going to write down derivative notation. What is a low? What is it? Low d high. What is low? 6x what? Okay. What is d high? Good. And then minus high.
3x plus 1.
Okay. So it'll be low d high. High d low. What's low? Derivative of low is what? 6 over 6x minus 4. Don't forget the bottom and don't forget square and do not expand. If you expand, it's actually worthless. You can expand the top though. So that's going to be 18x minus 12 minus 18x and minus 6. So over 66x minus 4 square. So that's 0, negative 18 to the 6x minus 4. Yep, square. See, I already forgot. I'm dozing off. So tired. Yes.
So with what we were doing before, if we had something in the denominator and we're just making it a negative power and moving it up. So would this rule also work with that?
No, because you need a chain rule in order to do that. So you cannot move up. So let's talk about when to avoid quotient rule. This is the case you do not avoid. You have to use quotient rule. So this is have to use quotient rule. And besides, this is called quotient rule for a reason because it's fraction. You have something fraction, it's called quotient rule. So let me write down the name. It's quotient rule. Now, when is a time that you should avoid quotient rule? Avoid quotient rule only in 3 situations. When the denominator is equal to 1 term, which is just like yesterday's homework. If we do quotient rule on that first question, it's more disgusting. Then we could have just simplified. You should have used that quotient rule. So for example, if I have f of x equal to x squared minus 4x over square root x, I will split. I will split first and do power rule. Any day, any moment, any time. Because quotient rule is going to be pain in the butt to do. And just not pretty. Second situation I will avoid quotient rule is when the denominator is a number. So for example, f of x equal to x squared minus 4x over 3. That I will avoid quotient rule. When something over 3, I just says f of x equal to 1/3 times x squared minus 4x. And if I want to take a derivative, I just do 1/3 in the front and take a derivative inside, which is 2x minus 4, and I'm done. I don't need to do quotient rule. When the bottom's a number or bottom's 1 term. After chain rule, we can talk about last case. That's when numerator is equal to a number. But you need the chain rule. So those 3 cases, you should avoid quotient rule. Is this one any of those 3 cases? Nope. Bottom's 2 term. Bottom's not a number. I cannot avoid it. Quotient rule. Got it? Quotient rule is low d high minus high d low over low low. Is the rule you just use. So I'm going to ask you to do this one. F of x equal to 3x squared plus 5 over 2x minus 1. So I want you to do quotient rule. I want you to simplify the top.
What was the third rule?
The third rule, when numerator is equal to a number. Now, numerator equal to a number, you need a chain rule though. It'll be easier. But let's just take a derivative with quotient rule here. Today, you're still going to get asked equation tangent line. Can I avoid quotient rule here? We get alpha at 124, right?
Yeah.
Okay, I'm just gonna do it. Low, D high, minus high, D low, over low low. Did you guys forget anything? Huh? I don't know. 12x squared minus 6x minus 6x squared, right? And the minus 10 over 2x minus 1 to the square. That's equal to 6x squared minus 6x minus 10 over 2x minus 1 to the second. And that's quotient rule. Is this hard? Nope. Okay. So chain rule is going to be one that's kind of pain in the butt. But we're not going to deal with chain rule until Monday anyway. What's up?
After school tomorrow. I came yesterday, but I had to leave early because my dad, like, he had to go pick up my little brother. So I did come yesterday, but I had to leave earlier than I thought I was going to. So I'm coming to.
That's fine. See you.
No joke to these.
Codes. He was is an interesting person.